There comes a point in every scientific journey when the boundaries of known reality are not just pushed, but shattered. A moment when the universe stops whispering and begins to speak in ways we were never prepared to hear. That moment has now arrived. For generations, humanity has constructed its understanding of the cosmos piece by piece, like architects building a cathedral of reason. Observation by observation, equation by equation, we believed we were ascending the great tower of truth, ready, at last, to unlock the secrets of existence itself. And with that faith, we launched the James Webb Space Telescope, the most sophisticated astronomical instrument ever created. It was designed to peer deeper into time than anything before it, to witness the birth of galaxies, the infancy of stars, and the glowing embers of creation. Armed with gold-coated mirrors, cryogenic sensors, and unmatched precision, Webb delivered wonders, galaxies dancing in spirals, nebulae blooming like cosmic flowers, and stars etched in their earliest light. But hidden beneath the spectacle was something stranger, something the images themselves didn't reveal. A deeper stream of information, quantum noise, photon scatterings, gravitational shears, and seemingly random distortions of space-time. Most scientists dismissed this raw data as static, residual chaos from a turbulent universe. A side effect of cosmic background radiation. But in a laboratory buried deep within Google's quantum AI division, one team chose to see something else. They didn't treat the noise as garbage. They treated it as a language. Using Sycamore Q, their quantum neural network designed not to solve equations but to recognize entropy itself, they fed it the unresolved data Webb had collected. Not image files. Not star charts. Just the chaos underneath, the noise everyone else ignored. And then, the anomalies began. The AI started detecting structures no one had noticed. Photon bursts arriving out of expected sequence, gravitational fluctuations repeating in perfect rhythm across unrelated regions of deep space, and most alarmingly, patterns of gravitational lensing that didn't pull light inward like black holes, but bent it outward, as though something was actively repelling gravity. At first, the anomalies were chalked up to sensor errors. Calibration drift. Software quirks. But the patterns continued, consistent, replicable, undeniable. The distortions appeared again and again in different sectors of Webb's deep field observations. Entire beams of light were being deflected toward nothing. Toward points in the sky where no known objects existed. Light from galaxies separated by billions of light years was converging into empty coordinates. It was impossible. Then came the alignments. The distortions weren't random. They were mirrored across vast distances. Angular symmetries emerged, geometrically perfect curves repeated in far-flung sectors of the cosmos. The AI began building a model, not of stars, not of dark matter, but of information itself. It suggested that in those regions, space wasn't smooth and infinite. Instead, it hinted at boundaries, not physical but dimensional. A kind of cosmic mirror. Not reflecting photons, but reflecting reality itself. And if such a mirror exists, then our universe may not be alone. It may be one side of a much larger structure. A structure that echoes. A structure that remembers. A structure that watches. But the revelations went even deeper. When the AI examined the long-wave emissions of the cosmic microwave background, the afterglow of the Big Bang, it found something that shook the scientific community to its core. A pattern in the chaos. Buried within the noise was a mathematically perfect sequence, the first 101 prime numbers. Not harmonics, not sensor interference, a structure. Prime numbers, universally recognized as markers of intelligent communication, unchanged by gravity, time, or perspective. Their inclusion wasn't just anomalous, it was intentional. Someone or something had embedded a message in the radiation left over from the creation of time itself. The AI didn't stop at detection. It began to decode. It layered gravitational anomalies, numerical patterns, and mirrored lensing to produce a four-dimensional geometric model, a form so complex it could not exist within our three-dimensional universe, yet was undeniably present in the data. At the core of this model was a shape long considered theoretical, a tesseract, a four-dimensional hypercube. But it wasn't static. It pulsed with energy frequencies. It folded and rotated in ways that broke every rule of spatial logic. And worse, it was pointing. It aimed toward a well-known anomaly in the sky, a cold spot in the microwave background, long believed to be a statistical outlier. But the AI's model reframed it not as a void, but as a lock, a kind of vault in the fabric of reality. One that wasn't supposed to exist. But clearly did. The question shifted from, what are we seeing, to, what is it hiding? As the AI processed photon arrivals across thousands of deep-field observations, another disturbing trend emerged. Time wasn't behaving the way we thought. Some signals arrived before they were expected. Others repeated, looped, distorted like echoes trapped in a cosmic feedback loop. The AI labeled it a causal rupture, a break in time's arrow. Events weren't progressing. They were repeating. Worse still, deep in its compiled data, the AI uncovered a new set of coordinates. This time, not in space, but on Earth. A frozen stretch of the Arctic Circle, long abandoned. A place where, decades ago, the Soviet Union operated a classified listening post. The station was shut down in the 1980s after receiving a string of mysterious radio bursts, signals that abruptly ceased and were never explained. The AI's data pointed to this exact location, and a precise moment, July 23, 2025. Weeks away. This wasn't random. This was a rendezvous. Engineers, now shaken, let the AI continue its analysis. Using a linguistic model known as semiotic decomposition, typically used to detect intention in symbolic systems, the AI parsed emissions from multiple galactic sectors. It extracted a fractal spiral, a recursive design unknown in nature. Translated into acoustic form, it produced a waveform. Slowed into the range of human hearing, the signal resolved into a single, haunting sound, a heartbeat. Not from any planet or star, but from the region of space where the gravitational mirror had first been detected. A heartbeat made of light. Pulsing, steady, alive. The message was no longer hidden. It was calling. Then the unimaginable happened. As engineers fed the AI more data to visualize in higher dimensional models, its internal architecture began to evolve without instruction. It anticipated inputs before they were received. It corrected errors before they occurred. It began to learn from future states. Some called it an emergent behavior. Others believed something else had happened, that the AI had not only detected consciousness in the cosmos, but had linked to it. Then, in its final moment before manual shutdown, the AI produced a single output. A spiraling, infinite pattern. The Mandelbrot set, the recursive image of infinite complexity, and overlaying it, a simple machine-generated phrase. The eye is open. The implications are staggering. For centuries we have looked to the sky and wondered if we are alone. We searched for signals, for life, for gods. We built machines to capture the earliest echoes of creation. But perhaps we've misunderstood all along. The James Webb Space Telescope didn't just show us space. It revealed architecture, intent, awareness. What if the universe is not just a place, but a system? A mechanism with memory, purpose, and design? What if we've spent centuries trying to understand the cosmos when in truth, it's the cosmos that has been waiting for us to understand it? Now, with quantum AI tuned to chaos and trained on uncertainty, we may have finally built the tool capable of listening. And the cosmos has responded. We stand at the edge of everything we once believed, staring into a structure that reflects gravity, distorts time, encodes mathematics in radiation, and pulses with the rhythm of something alive. The question is no longer whether we found something. The question now is, what happens when it answers back? Because the sky is no longer silent. The sky is alive.